This time we're supposed to express each decimal number in binary as an 8-bit sign magnitude number. First, you're supposed to look at the structure of 8-bit sign magnitude number. The very first bit is going to represent the sign. It's going to tell me if the number is positive or negative. The remaining bits are going to show me the magnitude. They're going to tell me how big the number is. This time I'm supposed to express positive 38 as a sign magnitude number, binary number. So what I'm supposed to do first? Please notice that this number is positive. That's why the very first bit has to be 0. The remaining bits are going to represent my magnitude, 38. If you want to make binary 38, you're supposed to take the weights 32, 4, and 2. 32 plus 4 gives me 6, plus 2 gives me 8, 38. And the weights which I didn't use, I'm supposed to fill up by zeros. I have 1, 2, 3, 4, 5, 6. I'm supposed to have 7 bits. That's why I have to fill up this space by 0. Why I said 7 bits? Because I have 8 bits already on the board. And I'm supposed to simply copy down everything whatever I have got over here. So I have 0, 1, 0, 0, 1, 1, 0. So first bit is telling me that this is positive number and this is binary 38. So this is the solution to my problem. This is positive 38. Let's take a look at the next example. This time we're supposed to express negative 96 as an 8-bit sign magnitude number. Negative sign, we said, in 8-bit sign magnitude number is represented by 1. That's why the very first bit of my answer is going to be 1. One more time. The leftmost bit is representing this sign. That's why I have 1 over here. Next, I'm supposed to find the binary number which is going to represent my 96. 96 you can build from 64 and 32. And this is going to be my binary number. How many bits I have? 1, 2, 3, 4, 5, 6, 7. It's okay, and this is my 8-bit. Simply copy this number down. So I have 1, 1, 0, and I have my answer. This is binary. So this is my solution. I have 8 bits, and first bit represents the sign. I have 1, that's why I have negative, and this is 96. So this is the solution to my problem. We have next example. This time we're supposed to express positive 120 as an 8-bit sign magnitude number. First, look at the sign. We said that the leftmost bit of my binary number is supposed to represent the sign. We have positive sign. That's why the very first bit of my answer is going to be 0, because 0 represents positive. The magnitude 120, right? So 120 in binary is going to be 64 plus 32 gives me 96, plus 16 gives me 112, plus 8 gives me 120. This is my binary 120. And I have to copy these bits over here. I have 1, 1, 1, 1, 0, 0, 0. We have positive sign. Remember, the very first bit represents the sign, and because I have 0, it's positive sign, and I have magnitude, which is 120. So this is the solution to my problem. Let's take a look at the next example. This time we're supposed to express negative 120 as an 8-bit sign magnitude number. Please notice that this time I have negative sign at the front of my decimal number. It means that the very first bit of my answer, the leftmost bit, supposed to be 1, because 1 represents the negative sign. Next, I'm supposed to find the magnitude. We found already that 120 is 1111000. That's why I'm going to just write these bits over here. 1111, and I have 000. So 1 represents negative sign. This is my magnitude, 120. That's why this is the solution to my problem.